It's 8 p.m. on a Tuesday. We are in hour 2 of the evening homework routine, and the student is hitting a wall. They're rubbing their eyes, staring blankly, and the math problems are no longer making sense. The default parental reaction to this scene is almost universally behavioral. We diagnose the sudden drop in focus as a lack of discipline. We blame laziness or assume too much screen time. However, the brain's higher-order functions are being physically suppressed. The wandering focus may have nothing to do with a child's willpower. The suspect is the air in the room, specifically the carbon dioxide they are continuously exhaling, which is pooling and concentrating inside an unventilated space. The sudden inability to concentrate actually appears to be a direct reaction to the shifting chemistry of the child's immediate environment. Environmental scientists measure this specific phenomenon against a threshold known as the 1000 ppm cliff, where indoor carbon dioxide begins to physically impair the human brain. To map exactly how this impairment works, researchers at the Berkeley Lab conducted a study in 2012. They placed adult professionals inside controlled testing chambers and monitored their cognitive performance at 600, 1,000, and 2,500 parts per million of CO₂. This chart shows the test results. As carbon dioxide levels in the room rose from an optimal 600 parts per million to 1,000, performance plummeted. The deepest declines hit complex skills. Strategic thinking and crisis response collapsed, the exact same functions a child relies on to navigate a challenging math worksheet. 4 years later, the Harvard CogFx study replicated this experiment, confirming the Berkeley data. Cognitive scores in well-ventilated, low CO₂ environments were 61% higher. This cognitive limit is thoroughly documented that the World Health Organization uses these specific studies to establish 1000 ppm as the maximum indoor threshold. The world's top scientific and medical institutions have demonstrated that typical indoor air slowly strips away our capacity to think clearly. Now, let's take those laboratory findings and apply them to a typical 30 cubic meter Indian bedroom. The door is shut for quiet, and the air conditioning is running on recirculation. An average person exhales 17 liters of carbon dioxide hourly. In a sealed 30 cubic meter room, that gas has nowhere to go. Within 2 hours, a child breathing normally pushes the concentration past 1,400 parts per million, well over the cognitive cliff. Scaling that equation up to a classroom packed with 30 to 50 students creates a severe compounding effect. Those rooms can hit toxic CO₂ levels in minutes. Educational data reflects this physical reality. Schools operating with chronically poor ventilation show a consistent, measurable drop in international math and reading scores compared to well-ventilated buildings. Placing students in closed, unventilated boxes, whether at school or a study desk, ensures they spend their day fighting a predictable cognitive fog. Focus is a physiological state. Air quality affects the brain directly, meaning the problem cannot be solved by yelling or confiscating phones. Checking a standard weather app won't diagnose this issue either. Those readouts only measure outdoor pollutants. They tell you nothing about the invisible trap building up inside your home. To take control of the environment, you need an NDIR monitor. These sensors use infrared light to track indoor carbon dioxide in real time, providing the data required to act. The most immediate fix is simple dilution. Cracking the study room door breaks the sealed loop, allowing fresh oxygen from the rest of the house to flush the space. But that introduces the Delhi winter paradox. When outdoor particulate pollution, like PM 2.5, spikes to hazardous levels, opening a window or a door means trading a CO₂ headache for a lungful of toxic smog. Standard air purifiers only recirculate the same air, cleaning the dust but leaving the CO₂ untouched. For households in high pollution zones, a dedicated fresh air system bridges the gap, filtering outdoor PM 2.5 before it enters, while continuously flushing out indoor carbon dioxide. If your child is constantly struggling halfway through the evening, stop guessing at behavioral flaws. Put a monitor on their desk tonight and check